Student, this is our third lecture of this week. Here I present last chapter of this course, that is chapter number 11, and the title of this chapter is Cluster Analysis. It is a last chapter of multivariate analysis. Listen attentively. The topics which we have covered in this course till now, we have assumed that the objects are classified in some manner having some similar characteristics. But in this chapter, we will assume that we have data in a raw or unclassified manner. Now, if we have the data in raw or unclassified manner, our first object before applying any statistical technique is to classify the data into groups having some similar characteristics or classified into different groups having similar characteristics. One such technique of classifying the data into groups is called cluster analysis. Cluster analysis is distinct from discriminant analysis, which we have not covered in this chapter. It is a topic which comes in the course of advanced multivariate analysis, which is assigned for MPhil students. Cluster analysis is distinct from the discriminant analysis because in cluster analysis no assumptions are made concerning the number of groups or group structure. Clustering or grouping is done on the basis of the similar or distances, similarities and distances. The input required are similarities measures or the data from which similarities can be computed. In most practical applications of cluster analysis, the investigators know enough about the problem of distinguish good grouping from bad grouping. Clustering techniques are very useful in many statistical works. With clustering techniques, we can arrange a huge amount of data into limited number of homogeneous groups to give a more concise and understandable account of the observation under consideration. In other words, simplifications with minimal loss of information is sought out. An example of such use of cluster is suggested by Morrison in the field of the market research. A large number of cities are available that could be used as a test market, but due to economic factors, testing must be restricted to a small number of these cities. If the cities could be clustered into a small number of groups such that cities within a group were very similar to each other, then one city from each group could be used as a test market. Cluster analysis can also be used to classify the more than one samples in a homogeneous groups. Now, the similarity and distances measures. Similarity measures most efforts to produce a rather simple group structure from complex data set necessary to require a measure of the closeness or similarity. When items are clustered, proximity is usually indicated by some sort of distances. On the other hand, variables are usually grouped on the basis of the correlation coefficients or like measures of association. Distance and similarities. Distance can be calculated from the formula given here: x1 minus y1 square plus x2 minus y2 square plus and so on xp minus yp square if we have p pairs of variables. The remaining text I hope you will be read from books, and the remaining text is easily understandable by you because the basic concept I have been given here. Now I come to an example which is given here, and relevant formulas will be explained in that examples. Suppose 5 individuals having the following characteristics. Here we have 5 individuals. The height is given of 5 individual, weight and eye color, hair color, handiness and sex are given here. Define the approximate binary variables, calculate the similarity. Here we have to calculate the similarity coefficient for all possible pairs of individuals. Here we have to make certain pairs, classify the individuals into homogeneous group. Now solution is given here. We have to make some distinctions in groups of the variables, in individuals with respect to the certain variable, that is x1. x1 is the height. We supposed, और we have to be given in example. हमें एग्जाम्पल में भी दिया हो सकता है और हमें खुद से भी हम इसे क्लासीफाई कर सकते हैं. अगर हम खुद से इसे क्लासीफाई करेंगे तो उसके हिसाब से हमारी क्लासिफिकेशन करेक्ट होनी चाहिए. As we have classified x1 as 1, x1 is equal to 1 if height is greater than 72 inches and 0 if height is less than 72. Similarly, x2 is equal to 1 if weight is greater than 150 pounds and 0 if weight is less than 150 pounds. And x3 is equal to 1 if the person have brown eyes, x3 is equal to 0 otherwise. x2 is equal to 1 if the blonde hair, or x4 is equal to 1 if the blonde hair, the individual have a blonde hair, x4 is equal to 0 otherwise. Similarly, x5 is equal to 1 if the person is right-handed, otherwise if it is a left-handed, x5 is equal to 0. x6 is equal to 1 if the individual or a person is a female, x is equal to 0 otherwise if he is not a female, he is a male. To calculate the similarity coefficients, one could find the scores for the first two individuals. I have take first and two individuals. x1, the value of x1 for individual 1 is equal to 1 and 2 is equal to 0. How we have these two values for individual 1? Individual 1 has 68 inches and the height is less than 72 inches. Therefore, against individual 1 under x1 it will be 0. And the second variable is weight 140 pounds. The weight of first individual, the weight of second in the weight of first individual is weight of 140 pounds, and if it is 140 pounds less than 150 pounds, it will also be 0. Similarly, x3 is equal to 0 for individual 1. What is x3? x3 is a eye color. Now classification of eye color is equal to 1 if brown eyes, otherwise 0. As it is as the individual 1 have a green eyes, so it will become 0. Similarly, we can take 0 and 1 with respect to the classifications. And in the same manner, consider x2 against individual second individual. Against second individual, x1 have 1 because the second individual have height 73 inches and height is equal to x1 is equal to 1 if height is greater than 72 inches. Therefore, here we'll write 1. Similarly, we have write 1 0 1 1. Now, contingency table. Here we have given a contingency table 1 and 1. How many 1 and 1 have been generated in above table? 1 and 1 only x5 below x5, so it is 1 1 1 1 1 and 1 1 and 1 0 and 1 individual for individual 1 0 for individual 2 it is 1. So that is 1 and 1 and 1 1 and 1 sorry 0 and 1 0 and 1 0 and 1 0 and 1. There are 3 times 0 and 1, so it will become 3. Now for individual 1 1, individual 2 0, that is 1 0 1 0 against x4, 1 0 against x6. Therefore there are 2. Here we'll write 2. Similarly, for x1 for individual 1 0, for individual 2 0 0 0. There is no 0 0, so it will become 0. That is the contingency table. Use similarity coefficients as given above. The similarity coefficient is equal to a plus d divided by p. A plus d, that is 1. Here write a plus d divided by p. Now a is equal to 1 plus d 0. The table, the contingency table have C above, that is contingent. First value 1, second b, and third c, fourth d. No. A3, B2, C3 and D0. Therefore 1 plus 0 divided by 6. What is P? P I think number of variables. There are 6 variables. The variables are which one? Height, weight, eye color, hair color, and handiness and sex. These are 6 variables. So divided by 6, it have become 1 over 6. Therefore, the similarity coefficient 1 over 6 in among individual 1 and 2. The similarity coefficient of individual 1 and individual 2 is 1 over 6. Similarly, we can find the similarity coefficient of individual 1 and 3, 1 and 4, 1 and 5. Similarly, 2 and 3, 2 and 4, 2 and 5, and 3 and 4, 3 and 5, 4 and 5, 4 and 6, 5 and 6. Hope you will find the remaining similarity coefficients among individuals, and it will be right in the form of the metric. Here the metric of order 6, 5 cross 5, because there are 5 individuals and the respective similarity coefficients are given here. This is the end of first example. Now come on second example, where we have R for a similarity coefficient. Product movement correlation formula: R is equal to AD minus BC divided by A plus B into C plus D into A plus C into B plus D raised to the power 1 by 2. It will be used here in this example. So come on example number 2. The example number 2 is the marks obtained by 6 students, 4 subjects: history, English, geography and economics. The respective marks of the 6 students are given here. We have defined the binary variable xi. Xi means for all subjects, all 4 subjects, that is history, English, geography and economics. If the marks is greater than 50, it will become 1. Marks is less than 50, it will become 0. Now here we have construct a table for binary values. Height for history x1, history, that is x1, is equal to 1, because in history the first students have mark 64, which is greater than 50, so it will become 1. Similarly, for second students, the marks in history is 46, which is less than 50, so it will become 0. Similarly, the contingency table has been generated here, and it is divided into contingency table of variable x1 and x2, and we have calculate R12, product movement correlation coefficient 0.707. Similarly, we can find the remaining values of correlation coefficients. Please see the detail in the PDF file which will be shared with you. I will share with you. the metric of the correlation coefficients between variables 1, 2, 3, 4 with respect to the 4 subjects is given here. Please try to understand. Hope it is clear.